Hello and welcome. Today we're going to be talking about the client-server model. Why do we need it? Why do we use it? What is it useful for? So, what is the client-server model? Well, it's a distributed application structure for partitioning tasks across multiple processes or machines. Okay. When we talk about tasks, we have client tasks, which is any task that's initiated by the client of a system, and it's an interaction or update to the client view. Server tasks are any task that changes the underlying data that is driving the application. And those can happen on the same machine, or they can be across a local network, or they can be globally dispersed. They can be spread across machines in multiple data centers around the world, and the client can be located on a laptop or mobile phone somewhere. So all we're talking about here is it's a big fancy word that just means the way we split up tasks is distributed either locally or globally. Okay, that's all we mean by that. So why do we want the client-server model? Well, it's essential for working on internet distributed applications. Let's say you are a user and you open up your Facebook app on your phone. That is you opening and accessing the client to a client-server architecture. You make a request to load your home feed. That request will go out across the internet and hit Facebook's server on the back end. Now, Facebook's server will have a lot of possible services sitting behind it that it can serve. Okay, things that it can do, such as grabbing a list of all the feed items. That could be a service. Or if you want to print a picture, a funny meme, something like that, from your phone to your local printer, that would actually be a local client-server architecture. Your local client, which is still the Facebook app, would interface with the hardware that talks to your printer on your network and will send the request there. Okay? So those are what we mean by services. So a server is any machine-hosted application. It can be hosted locally or it can be hosted on a remote. Okay? The application provides some level of abstraction over that machine's resources. And it's either as a function or as a service. That's how those abstractions are exposed to the overarching server application. And you can share those services with multiple clients. So the resources that you're talking about can be shared out to any number of clients that want to connect into a single server. So what are we talking about resources? What do we mean by those? Resources are anything such as storage. It can be file systems. It can be a wide variety of things that are executed from that machine. Okay. So these are the kinds of things we talk about. It's a service represents a single server resource. Those are files, other programs that can be running on the machine. You can share CPU cycles. So if you're doing heavy data processing, maybe you want to share the CPU cycles of multiple machines. Those CPUs can be exposed as services. Memory. So if I want to store something in memory, for instance, Redis is nothing but a remote memory store. Okay. You can also write things to disk, which is what hard drives usually do. You can write things to disk using large global services like AWS's S3 service, which is a way to store things, files, in a remote location. File servers do the same thing. Printers can be shared across an entire network or even remotely across the internet. Your databases, as I've mentioned earlier. Okay. There are a lot of possible server resources that can be shared as a service. Then the server decides, how am I going to allocate all of these finite number of resources to all the clients that are connecting into my system. So what's the client? Clients typically do not share their resources with other clients. Now, a client can share its resources with a backend server, but it does not share with other clients typically. It has its own set of resources it spins up and owns. And it says, I have this much CPU, I can use this much memory, I have access to these things, and these are mine. And it doesn't offer them out to anyone else. Requests go out to a server. Any service that it wants to request goes out to the server. And when the server is done, the client is the one that responds to those requests by updating the local client state. That might mean drawing new things on the screen. It might mean just changing the local data store to represent the current state on the server. Whatever that is, the client handles that. Okay? So what kind of examples can we talk about here? What are things that happen and use the client-server architecture? Well, email services are client-server. Networked printers, we mentioned those earlier. The World Wide Web is the ultimate example of client-server architecture. Any file server you access remotely with FTP or anything like that, that's client-server. Your online banking, if you use a banking app or you log in on your computer, that's client-server. And our personal favorite, using Netflix, something like that, any kind of streaming video service is a client-server architecture. Well, that's it for today. That's all we're going to cover. I hope you enjoyed this. If you did, can you go ahead and hit that like button down below? Subscribe to the channel to see more content like this and other programming-related tutorials. Thank you all so much. I look forward to seeing you in the next video.